On the evening of July 31st, 2026, the ground under one of the most densely populated places in Europe moved. Not shook and settled back, moved permanently, and the agency responsible for monitoring the volcano beneath it took that movement out of the official record. That is the story. Let's get into it. We're talking about Campi Flegrei, the supervolcano sitting directly under the western edge of Naples, Italy. 500,000 people live inside this caldera, not near it, inside it. Schools, hospitals, apartment blocks, all built on top of a system that has been rising, cracking, and venting gas for 2 decades. At 7:46 p.m. on July 31st, a magnitude 4.7 earthquake struck near the Solfatara crater at Pozzuoli at a depth of around 3 kilometers. It was the strongest tremor recorded in this area in 40 years. Italy's National Institute of Geophysics and Volcanology, the INGV, confirmed it surpassed the 2 magnitude 4.6 events recorded back in 2023. Civil protection officials called it the most powerful earthquake since continuous instrumental monitoring began. A magnitude 3.8 aftershock followed at 10 p.m. It was one of more than 30 tremors recorded that evening. At least 21 people were injured. Train service across the Naples network was suspended. The port of Pozzuoli shut down, cutting ferry access to the islands of Procida and Ischia on one of the busiest travel weekends of the summer. To put that quake in context, this is a caldera roughly 130 square kilometers wide. Not a mountain, not a cone. There's no peak to point a camera at. It's a vast, shallow depression carved by 2 massive eruptions tens of thousands of years ago, and the modern city of Pozzuoli, along with a chunk of western Naples, sits directly inside it. That's the part outsiders often miss. This isn't a volcano on the horizon that a city happens to be near. The city is built inside the volcano's collapsed crater. And the ground under that city hasn't been sitting still. Since 2005, it has been rising continuously, averaging around 10 millimeters a month, for a cumulative uplift of roughly 140 centimeters. Streets in Pozzuoli have buckled. Apartment buildings have visible cracks running through their facades. The harbor has to be dredged periodically because the seafloor itself keeps climbing. This is a slow-motion process that residents have been living inside for 2 decades, and July 31st was the moment it stopped being slow. Those are the headline facts. They're not the real story. Here's the real story. When that earthquake hit, the ground didn't just shake and return to where it started. Some of the monitoring stations spread across this volcanic field physically shifted position. Horizontally, between 1 and 3 centimeters. One station near Rione Terra recorded a horizontal displacement of nearly 3 centimeters. Other sections of ground dropped vertically by 1 to 2 centimeters. Small numbers. Here's why they matter. After the quake, the INGV removed that permanent displacement from the official deformation record. They call it a co-seismic disturbance, a sudden movement caused directly by the earthquake. And their position is that it shouldn't be counted toward the long-term uplift trend. Strip it out, they say, and the underlying pattern hasn't meaningfully changed. Professor Luongo disagrees, and he isn't quiet about it. He's one of Italy's most experienced volcanologists, decades of direct work on this exact system, former leadership at the Vesuvius Observatory. He says removing that data is extremely serious, not just because it erases information needed to understand the earthquake's mechanism and energy, but because, in his words, it suggests the people responsible for monitoring this process may not have the expertise to understand what they're looking at. That's not a vague complaint. That's a senior scientist publicly saying the people running the monitoring might not understand the system they're monitoring. The backlash against him has been sharp. Some have tried to paint him as out of touch, but he isn't alone. Other scientists inside the system have said quieter versions of the same thing. And in Pozzuoli, people are angry enough to block the port. So let's understand why Luongo thinks a few centimeters of ground movement matter this much. Picture the cap rock. This is a layer sitting roughly 1 to 2 kilometers below the surface, and it functions as the lid on the volcanic and hydrothermal system underneath. Below it, a gas-rich reservoir at 2 to 4 kilometers depth. High-resolution geophysical imaging has mapped this structure directly. Reservoir below, deformed, low permeability cap above. That cap rock is the only thing standing between the pressurized system and the surface. Now think about what 20 years of continuous uplift have done to that lid. The ground has been rising since 2005, about 10 millimeters a month, roughly 140 centimeters cumulative. That means the rock in the cap has been stretched over and over as the ground bulges upward beneath it. Multiple studies suggest this cap rock may retain only about a third of the structural integrity it had in the 1980s. It has been fracturing for years. On July 31st, the strongest earthquake of this entire unrest episode hit that already stressed rock, and part of it moved permanently. Blocks shifted sideways. Sections sank. Scientists call this a structural adjustment. Luongo is careful about what this does and doesn't prove. It is not evidence that magma broke through, and nobody credible is claiming that, but it is direct information about how the crust is failing, where the stress is redistributing, and how close to failure the lid actually is. Take that data out of the record, and you're looking at an incomplete picture of the one layer standing between the system below and the city above. And critically, the uplift didn't stop after the quake. The earthquake didn't release pressure or let the system relax. It kept rising. Same trend, same rate, except now part of the crust sits in a new position. This is where a second scientist, Giuseppe De Natale, adds a piece that changes the whole timeline. De Natale has also spent his career on this caldera, and shortly after the July 31st quake, he laid out the historical comparison that should worry you more than the earthquake itself. The last eruption at Campi Flegrei was in 1538 at Monte Nuovo. It lasted 8 days and built a 133-meter hill from flat ground. Before it, there was roughly a century of ground uplift and seismic unrest. Now, compare that to today. The ground began rising again around 1950. There was a major uplift crisis from 1969 to 1972, another from 1982 to 1984, and since 2005, the uplift has been essentially continuous, faster than any of those earlier episodes. De Natal says that as far as the data and tell us, this pattern closely resembles what preceded the 1538 eruption. He's careful to add the obvious caveat: one historical comparison doesn't give you a reliable prediction. An eruption is not certain, but he's equally clear that it cannot be ruled out, and it should not be treated as simply unlikely. Here's where it gets uncomfortable. Before the 1538 eruption, total ground uplift may have reached around 16 meters. Since the 1950s, today's cumulative uplift is only about 4.5 meters. At first glance, that sounds like there's a long runway left. De Natal says don't trust that comparison. Think of a balloon you inflate, deflate, and inflate again. The second time, the rubber gives more easily. It's lost elasticity. The upper 3 kilometers of rock at Campi Flegrei have been through multiple cycles of uplift and earthquakes since the 1950s. They've been heated repeatedly, dalle by volcanic gases. They've been fractured again and again by tremors that are now getting stronger. Every one of those processes changes the mechanical strength of the rock, the exact property that determines when the lid gives way, which means nobody can say with confidence that this system needs anywhere near 16 meters of uplift before something breaks. The rock today may not tolerate anywhere close to what it tolerated in 1538. That's why a few centimeters of permanent structural ground movement during the strongest earthquake of the crisis isn't a footnote. It's a direct readout of the current mechanical state of the lid, and it's the readout that just got edited out of the public record. And this isn't the first time the reliability of official monitoring has come under scrutiny at Campi Flegrei. For years, residents and independent researchers have pushed back on the gap between what agencies publish and what people on the ground actually observe. Cracked W, halls that appear faster than official uplift figures seem to justify. Gas smells reported well before fumarole readings are updated. None of that proves malfeasance. Volcanic monitoring is genuinely difficult. The instruments have real limitations, and scientists disagree with each other constantly as part of normal, healthy science. But it does mean that when a senior figure like Luongo says a specific dataset was removed and calls that removal dangerous, he's tapping into a trust deficit that already existed before July 31st. That context matters for understanding why this argument escalated as fast as it did. Before we get to what could happen next, there's a piece of this puzzle that almost nobody outside seismology circles is talking about. And it might be the most urgent piece of all: gas. Inside a sealed railway tunnel at the edge of the caldera, scientists have measured carbon dioxide concentrations of roughly 70,000 parts per million. Normal outdoor air sits around 420 parts per million. That tunnel reading is more than 160 times background level. CO2 is now turning up in schools, basements, homes, and public spaces across Pozzuoli. Residents are reporting dizziness. The levels are climbing. Why does this matter specifically? Because CO2 and SO2 escaping through fumaroles are gases released by magma, and both are elevated and rising. This isn't old gas leaking out of a sealed pocket underground. The pattern of increasing volume points to something actively being GI replenished. A deep magmatic system feeding new material upward, releasing gas as it rises, and finding new fractures to travel through, all the way to the surface, into tunnels, into basements, into the air that 500,000 people breathe every day. So what could this actually turn into? This is where most people get the scale wrong. When people hear phreatic eruption, they picture something small and contained, a steam explosion like White Island in New Zealand. Dramatic, but geographically limited. De Natal says that assumption could be badly wrong here. A phreatic eruption is a steam-driven explosion triggered when superheated water suddenly flashes to steam as pressure drops. At Campi Flegrei, that kind of sudden depressurization can act like a pump, pulling pressure down rapidly and drawing magma upward from deep. In the system. What starts as a phreatic event can escalate into a phreatomagmatic eruption, one that involves magma directly. Thermal modeling suggests a critically pressurized reservoir of potentially eruptible magma already sits at around 4 kilometers depth. That's close. Close enough that the escalation pathway is not theoretical. De Natale points out that the overwhelming majority of historical eruptions at Campi Flegrei have been phreatomagmatic, meaning many, maybe nearly all, likely began as a phreatic phase first. No new magma has to reach the surface to trigger the opening explosion. But once that first explosion starts, the chain reaction that follows is genuinely unpredictable. This is also why the earthquake swarm itself deserves more attention than a single headline number. More than 30 tremors in one evening isn't background noise. It's a system redistributing stress across multiple points at once, not just one clean rupture. Swarms like that are consistent with fluid and gas movement through a fractured rock mass, which lines up with everything. The CO2 readings are already telling us. Multiple independent signals, deformation, seismicity, gas chemistry, are all pointing in the same direction at the same time. Individually, any one of these might be explainable as normal background activity for an unusually active caldera. Together, on the same week, they're harder to wave away. Now to the part of this crisis that has nothing to do with geology and everything to do with people. Roughly 3,500 people have already been displaced by damage from the July 31st earthquake. Rental housing in the area is scarce, and landlords are reportedly raising prices on people who just lost their homes. Residents have blocked the port of Pozzuoli in protest. Not just at the earthquake, but at authorities they say have known for years that buildings in this zone weren't built to withstand repeated, shallow tremors. That's the key detail. These earthquakes are extremely shallow, only a few kilometers deep. A 4.7 is moderate by global standards. But a moderate quake, sourced a few kilometers below a dense, old, largely unreinforced city, does real damage. And the open question isn't just about this earthquake, it's about the next one, which could be stronger. When De Natale was asked how many homes and schools could collapse in a stronger quake, his answer was blunt: we simply do not know. He says a building-by-building vulnerability assessment across the whole area should have already happened. He wrote to authorities about this back in 2023. He isn't confident even public buildings and schools have been properly assessed, and private buildings almost certainly haven't been checked individually. Meanwhile, the official evacuation plan for Campi Flegrei rests on an assumption that scientists will have 72 hours of advance warning before an eruption. De Natale says that assumption doesn't hold, especially for phreatic eruptions, which can happen with little or no warning. Monitoring data is currently published in weekly and monthly bulletins. Nobody outside the agency knows hour by hour what the ground is actually doing right now. Luongo has made one specific, simple demand. The public deserves 2 numbers, updated daily. First, the current velocity of ground uplift. Not a weekly average, but a live figure, because a sudden increase in that velocity is itself a warning sign. Second, the depth of the pressure source E driving the deformation, because if that source is migrating toward the surface, the hazard changes fundamentally. He said there's no technical reason this can't be published in real time on a public website, like a live chart. The technology exists. It isn't being used that way. Then there's the longer-term problem, which De Natale calls politically explosive but scientifically unavoidable. The existing evacuation plan involves moving roughly 500,000 people within days. Here's the flaw De Natale points to. Imagine scientists calculate a 10% chance of eruption within the next month, with 500,000 people potentially. Eye in the path. Even 10% might be too high a risk to accept, but that also means a 90% chance nothing happens that month. What politician signs an evacuation order on those odds? And if the evacuation happens and nothing erupts, who decides when it's safe to go back and who takes responsibility for that call? That political impossibility is why De Natale is pushing a different approach. Gradually and voluntarily reduce the permanent population in the highest risk zones now, long before any emergency. Stop issuing new building permits in the red zone. Offer real economic incentives to relocate. USs. Special economic zones to pull investment toward areas outside the caldera. Do it slowly, over years, so that by the time scientists do need to sound the alarm, there are fewer people who need to move. The alternative, he says, is a potential mass exodus through a city whose roads, rail crossings, and infrastructure were never built to move 500,000 people at once. Now let's get to the mathematical modeling, because this is the piece that ties everything else together into a timeline. A paper published earlier in 2026 titled "Accelerating Unrest at Campi Flegrei Signals a Critical Transition Within the Next Decade" found that the acceleration of both seismicity and ground deformation at Campi Flegrei fits a finite time singularity model better than simple exponential growth. That distinction matters. It's not just a better statistical fit, it implies a fundamentally different underlying process, one with more serious potential consequences. Independent analyses converge on a critical time window of roughly 2030 to 2034, with uplift projected to reach around 4 meters by the early 2030s. In plain terms, a finite time singularity means the acceleration is itself accelerating, not just speeding up faster, like a car with a stuck accelerato R pedal. The faster it goes, the faster its speed keeps increasing. The math points toward a specific window, not an indefinite continuation. Somewhere in that 2030 to 2034 range, the current trajectory becomes mathematically unsustainable in its present form. The authors are careful here, and so should we be. This convergence point doesn't automatically mean an eruption. It marks a horizon where the system has to change state. What it changes into is the actual open question. A separate study from January 2026 adds a counterweight. Even though potentially eruptible magma appears to be sitting around 4 kilometers depth, the magma reservoir would likely need another 2 to 3 decades to grow to the scale of the one that fed the 1538 eruption. So a full repeat of Monte Nuovo isn't imminent by that measure alone. But go back to the balloon. The rock today isn't the rock of 1538. The failure threshold has almost certainly shifted, and shifted downward. And on July 31st, we got the most direct evidence yet that the egg crust is moving in new ways, permanently, structurally, right as that threshold is in question. The agency responsible for tracking that evidence removed it from the public record. That's the scandal. That's why Luongo is furious. That's why residents in Pozzuoli are blocking ports and demanding straight answers. Nobody in this story is saying an eruption is happening tomorrow. Not Luongo, not Di Natale, not the authors of the 2026 paper, but they're all converging on the same underlying message from different directions. The system is changing, the crust is weakening, gas output is rising, seismic energy is increasing, and the people responsible for communicating this to the public may be presenting a picture more stable than the data actually supports. 500,000 people fall asleep every night directly above the system. They deserve real-time information about what the ground is doing, not a weekly bulletin. They deserve buildings capable of surviving the next earthquake, not a promise that assessments are underway. They deserve the full range of outcomes laid out honestly, not just the reassuring end of it. The lid on the system has been cracking for 2 decades. On July 31st, part of it moved permanently. And underneath it, new material keeps arriving, keeps releasing gas, keeps pushing upward. So where does that leave the actual question in the title? Did the lid just weaken? Based on everything above, the honest answer is probably, but nobody can prove it with certainty yet. And yet uncertainty is precisely the problem. Luongo isn't claiming the cap rock failed on July 31st. He's claiming we lost a piece of evidence that could have helped answer that question either way. Di Natale isn't claiming an eruption is coming in the next few years. He's claiming the historico. LE pattern rhymes closely enough with 1538 that dismissing the risk would be irresponsible. The 2026 modeling paper isn't claiming 2030 to 2034 is an eruption date. It's claiming that's when the current mathematical trajectory of unrest becomes unsustainable in its present form, whatever comes next. None of these scientists are alarmists in the tabloid sense. They're doing what serious scientists do when they see conflicting evidence. They're arguing, loudly, in public, because the stakes are 500,000 people's lives, and because the agency responsible for the data just gave them a reason to distrust the official summary. That argument, playing out in real time, in front of the residents whose homes are cracking, is the actual story here. More than any single number, more than any single earthquake. Watch this space. The next few years, according to the math, are the ones that matter most.